Today we are going to begin module 1 of course automotive sensors. The first topic is introduction of automotive sensors and the evaluation of automotive sensors. In modern automobiles, sensors are considerably the eyes, ears and nerve systems of the vehicle. Whether it is an internal combustion engine vehicle, an electric vehicle or a hydrogen fuel cell vehicle, sensors continuously monitor different operating conditions and provide information to the electronic control unit, that is ECU. Without sensors, today's vehicle cannot achieve better fuel economy, emission control, and safety, comfort, or autonomous driving capabilities. By the end of this lecture, you will be understand what is automotive sensors, why they are important, and how they have evolved over these last 6 decades. After completing the session, I should be able to first define what an automotive sensor, explain why sensors are necessary in modern vehicles, describe how automotive sensors have evolved from simple mechanical switches to intelligent smart sensors, and finally comparison for a conventional vehicle with today's sensor intelligent vehicles. These concepts from the foundation for all the sensors that will be studied in this course. Before discussing automotive sensors, let us first understand the meaning of sensors. Sensor is a device that detects or measures physical quantity and converts it into an electrical signal. The physical quantities may be temperature, pressure, speed, position, and light, gas, concentration, acceleration. For example, a thermometer measures temperature, a weighing machine measures force, a smartphone automatically adjusts screen brightness using a light sensor. Similarly, vehicles also require sensors to monitor different operating parameters. The sensors converts the physical quantity into voltage, current, frequency, or digital signals that electronic system can understand. Let us define an automotive sensor. An automotive sensor continuously measures vehicle operating conditions and send information to the electronic control unit, commonly called as a ECU. The ECU acts as a brain of the vehicle. Let us understand this using simple block diagram. Suppose the engine intakes pressure changes, the map sensor detects the pressure. The sensor converts pressure into an electric signal. The ECU receives this signal, process it, and decide the appropriate fuel injection quality. Finally, the injector acts according to the ECU commands. Which is this that block diagram. It consists of physical quantity like pressure, temperature, speed, position, and sensor sends the physical quantities and send to a signal conditioning unit and ECU, and finally actuator. Why do modern vehicles require so many sensors? The answer lies in four major areas. First, engine control. Sensor measures the engine temperature, intake air pressure, oxygen concentration, and throttle position to improve combustion. Second, it's safety. Wheel speed sensor helps ABS prevent wheel locking. Airbag sensors detect collision within milliseconds. TPMS continuously monitor tire pressure. And third one is comfort. Rain sensor automatically activate windshield wipers. Light sensor automatically switch headlights. Cabin temperature sensors maintain passenger comfort. In ADAS, radars, cameras, and ultrasonic sensor enable lane keeping, adaptive cruise control, parking assistance, and collision avoidance. Therefore, sensors make vehicles safer, smarter, and more efficient. Next, we have to discuss about evaluation of automotive system, automotive sensors. In the 1960 range, vehicles were almost entirely mechanical. Fuel delivery was controlled by carburetors. Ignition timing was mechanical. Very few sensors existed. During 1980s, governments introduced strict emission regulations like electronic fuel injection replaced with carburetors, oxygen sensors, map sensors, and coolant temperature sensors become common. In the 90s, electronic control units become standard. Knock sensors, crankshaft sensors, and wheel speed sensors improved engine performance and safety. During 2000, safety systems expanded rapidly. Vehicles including airbags, ABS, TPMS, steering angle sensors, and yaw rate sensors. From 2010 onwards, vehicle become connected. Radar, cameras, GPS, and ultrasonic sensors supported advanced driving assistance system, that is ADAS. Today we have electric vehicles and autonomous vehicles using LiDAR, AI cameras, battery sensors, and V2X communications. The number of sensors has increased dramatically. This timeline clearly shows the evolution of automotive technology. Initially, a vehicle depends mainly on mechanical components. Later, we have electronic fuel injection system, required pressure and oxygen sensors. As computing power increased, ECUs managed engine operations. Safety systems introduced many additional sensors. Finally, modern autonomous vehicles combine information from multiple sensors simultaneously. Today's vehicles perform sensor fusion like where LiDAR, cameras, LiDAR, GPS, IMU data are combined to make driving decisions. And next, growth of automotive electronic. Over the year of electronic have become an essential part of automobile. In 1970s, electronics represented only around 5% of vehicle systems. Today, nearly half of the total vehicle volume comes from electronics. Modern luxury vehicles may contain more than 100 sensors, more than 70 ECUs, several kilometers of wiring harness, thousands of software functions. Electric vehicles require even more sensors become because battery safety is extremely important. Let us summarize the importance of milestone of electronic automotive technology. Initially, mechanical system dominated, then electronic sensors improved fuel economy, and next safety sensors protected passengers. Finally, AI-enabled sensors support autonomous driving. Each technological advancement has increased vehicle intelligence and reduced accidents. This is the comparison of conventional vehicle versus intelligent vehicle. Finally, advantages of automotive sensors. It improves fuel efficiency, reduced emissions, enhanced safety, and better vehicle diagnostic systems, increased reliability, lower maintenance cost, real-time monitoring, supports autonomous driving. These are the advantages of our automotive sensors. Thank you.